The project BREC connects agricultural schools, authorities, and researchers to spread circular bioeconomy and circular agricultural practices among stakeholders and test technologies driving circular bioeconomy. In this project, we want to tackle the challenge of going from a linear economy to a circular bioeconomy, more specifically the challenge of teaching and spreading circular agriculture practices that have a considerable less environmental impact than conventional agriculture. Our project consortium includes 5 different regions, and these are our partners. Yeah, now I want to tell you something about the target groups of the project. We want to reach plant operaters, local authorities, and teachers to include circular bioeconomy more in our education and in our economy. In general, these are all stakeholders that are interested in a change from linear to circular economy. And I have prepared 2 more question and answer parts. Which target groups are participating today in this workshop? This would be interesting. You can also find this question in the surveys. And which challenges and opportunities are important in your region for the future? For our region, there are several challenges. For example, the energy market is quite dependent, and the reliability of the input streams from different sectors is not going so well, and we are needing to adapt processes and standards, but this is often not so easy because of hard regulations and politics. Yes, the opportunities is for us evaluation of economic viability of converting to biogas, extending the substrates spectrum, and extension of digestate capacities. These are 3 goals that we are forcing in our region for the next years. So the political objectives are very ambitious, and it will be hard for us to reach the targets, but this is how it goes. We have to go through this, and for our region, the main topics in circular bioeconomy is efficiency, sustainability, independency, and stability. And I would like you to prefer which of these goals are very important for you and personally. You can also find this question in a survey. Please take a time to make a priority of your goals for circular bioeconomy, what is important for you, and you can choose one or more of these 4, or you can choose others. Yeah, and further goals for our region are improving the efficiency, to include more effective recovery and recycling processes, utilize heat and other power overload more efficient in other processes, and increases the opportunities for energy recovery from green waste, for example. This is a field that is in a development this last decade and the next decades in our region, because we have so many regulations that are restricting stakeholders for using a lot of free available biomass sources around the neighborhood. And one goal is to make them accessible for different processes, for example, energy production or food production also. Yeah, thank you very much for the introduction into the project. Now I want to give you a short impression of education in the agri sector. We want to change the linear economy to circular bioeconomy, and we see the agricultural education as the chance to reach this target, because when you want to implement all these concepts and innovative processes and technologies into the future, you need also the people who operate these concepts and understand their responsibility in the whole system. So we want to start at the education to link all these corresponding job profiles to each other, yeah, create just a better basement for research and also for operating in the practice. Yeah. It is not easy to explain what is education in the agriculture in general, because there are so many different job profiles you can work in because of very, very complex systems. And often there is mything for oneself that what is your responsibility in the whole system. And this is a goal of us to link this together and give them a connection to each other. And also not the job profiles in general are complex. Also the form of education is complex. The different qualifications you can achieve for example, vocational schools or technical colleges or a university level. And I mean, the informations and the principles are in general the same, but the complexity of how the information is transformed and transported is different. Yeah, now I would like to introduce Professor Dr. Leif Alexander Gabe. He is a Prorector for Research Knowledge Transfer and International Relation at the University of Applied Science in Neubrandenburg. And I am very happy that you are introducing us today in the education in Neubrandenburg.
So what is our mission statement, for example, with a look on this circular economy especially? So as you have heard, we are in the region between Berlin and the Baltic Sea. And yeah, we have a really important intersection, or we are on an intersection between the regional public and the international scientific community. And yeah, for us, it's really important to have this good contact to the public and to the companies, and to work together with them. When we have practical courses with the students, we go into the field, we go to the companies and show what's really going on in the world. And maybe not that so we don't have so many teaching courses in the classrooms. Yeah, especially in the practical courses. So applied sciences, what I said to you, research and teaching, it is really applied and multidisciplinary. And yeah, so maybe I switch to the next slide. We have a small this is what we call in German, it's an An-Institute, it's a cooperation institute where we look especially on food technology. It's a Center for Nutrition and Food Technology. And there, what we are doing is a scaling up. So that is maybe really important or interesting for you. So if you work in a university of applied science like us, or smaller or bigger universities, you usually work in gram or in kilogram scales. And if you go to tons, then you have a big jump in the technological readiness level. So if you have a lab technological readiness level, you're between 1 and 3 level. And if you go up to 4, 5, 6 TRL, then you go up to this pilot plant. And that's what we are doing here in our cooperation institute. Here we are trying to rise the technological readiness levels of processes in food technology, but also in agricultural questions. And that is, in my point of view, very, very important for all of you, because you have to build up industrial processes in the end. And that is a big or long way from university to industry. So therefore, I would like to figure out some trends and what is triggering us. So of course, you all know the population of people is growing. So we look on our food production. So can we maybe rise food productions? What about the yields, and what about the soils? So what about fertilizers, pesticides, land use, and food security? I have some slides for you also on that term in the next minutes. Climate change, we all know there's droughts, crop pest control, and the resilience questions we all have to figure. Decarbonization, it's a big question of our time. And also the consumer behavior. We currently see that in Germany, when we look or when we discuss heating with gas or with coal or with electrical energy, that is a big question now in our country. So the consumer behavior, what is the opinion of the consumer, and how does that trigger all our ways we have to go? And in terms of food, of course, something like superfoods. But that is a question of circular economy and these global value chains. And in the next slide, I don't want to bother you with details, but just to have an idea what I'm trying to tell you. So the global production of crops, this P4F is a physics for food. It is a project I'm covering with my employees. That shows you about the cereal yield, cereals, and on the right hand side in red, it is the soybean yield in tons per hectare. So it is not a picture a graphic which gives you information about the amount of the cereal yield, but it gives you an information on the productivity. So the darker the color, the higher the productivity is tons per hectare. On the left, the cereals, on the right, it's soybean. And you can see, of course, in Europe, we have a high productivity, a dark green in Germany, in France, and also in the US, but also in China. And in Egypt, we have these high productivities when we produce these cereal products in agriculture. And that's what we are also in cooperation with our students, what we say, okay, the question is, what is behind that? And if you look on the right-hand side picture, the red colors, you can see the soybeans yield again in tons per hectare, so productivity. And you all know, okay, Brazil, it's an interesting country for soys. Brazil is dark in red, also the US. But in Italy, for example, also especially in Turkey, they are dark in red, so they have a high productivity in soybean yields. And then the question, why is that the case? What is the reason for these high productivities and these global productions? And the next slide, you can maybe understand it. I hope you can see it, otherwise I show you or send you the presentation. That is on the left hand, that is the cereal yield versus fertilizer, of course. The higher the amount of fertilizers, it's a logarithmic information given on the left-hand side. The higher the fertilizers, the better your yield. And if you then look on China, China has a very high load of fertilizers, some of the highest in the world, much higher than Germany or Brazil or South Africa, which is given as an example here. And of course, the higher the amount of fertilizers, the higher the yield. But this is a problem, as you all know, with nitrate in the groundwater and other problems. So using fertilizers is not always the best way to raise your yield. Yeah. On the right hand side, you can see that is what about the arable land needed for production of a fixed quantity of crops. Of course, this drops with time since 1961. But you can see also in the European Union, since maybe 20 years, we have more or less this green line here with an equilibrium. It's not getting better. It's hard for us to get more yield from a fixed quantity, from a fixed land. Under the next slide, I just to have an idea for you what's going on is the use of pesticides in tons, and on the right hand side of nutrients. But on the left hand you can see this pesticide use, and Germany is here given with a red information, and the blue bars it's the average between 2013 and 15, and the black dots are the average of 2002 2004, so 10 years earlier. And there you can see very easy that, for example, the use of pesticides in Germany has dropped, whereas in France, it is on the left beside Germany, the amount of fertilizers. So no, I'm sorry, the other way around. And in France, it has a lower amount of pesticides. Yeah, this blue dot in France, it's higher in 2002, and now France uses less pesticides, and in Germany we use more pesticides 10 years later. And that is the data you can see maybe afterwards again, but that gives you an information in total how many pesticides are used in different countries. Look at Mexico. Mexico is this very tall blue bar. Now in 2013, 2015 average, more than 100,000 tons of active pesticides are used in Mexico, and other countries like, for example, in Denmark or Estonia and also in Finland, very low amounts of pesticides are used. So it was interesting for me that there's also such a strong variation in the use of these pesticides in the OECD countries. Now, that is what we figure out with our students, and we discuss always what is the reason and why are these countries do that, and what is the advantage, what are the disadvantages, and so on. So we look on very practical informations from different countries together with our students, and we discuss the advantages and the disadvantages. On the right hand side, just some information on the nutrient balance. Also interested in the European Union, you can see this is 28 countries. So that is the use of nitrogen, phosphor in kilograms per hectare, and on the right, you can see Korea. It has a high nitrogen nutrient usage, and beside it is Cyprus, and also Japan, Malta, and so on. As I said, in the European Union, of course, we are in an average, but countries like Ireland and Australia, Estonia, and here you can see Mexico, in the countries who use very low amounts of nitrogen and phosphorus. And that is also a point we are discussing with our students. What is the reason for that, and what are the impacts? Good. So that's from my side. So thank you very much for listening. again, we are focusing our education of agricultural students in combination with the food technology students, and also in combination with this dietitian or dietetics students, where we always try to give a view for them on the entire food chain. So from the production of the grains, of the transformation of these grains to food products, and finally what's the action of the ingredients in the human body. And this all in combination, less with a lot of science. Of course, it is a university. We are teaching also the basics and applied scientific aspects, but our focus is always very strong on applied sciences, what is going on in the companies, in combination or in cooperation with farmers, with SMEs in our region. And by that, we are giving our students a very, maybe practical view on their education and agriculture. So that's for my point. Thank you very much. I hope I was in time, Mr. Vogt.
And I was talking with you, Professor Alexander Leif-Gabe, together about this topic, and you bring in some very good input and ideas. And also, you at the university are doing great work in this way. For example, we want to try to make the circular bioeconomy as a word more touchable and not more understandable, because this is not the issue. The people that want to learn an agricultural job, they already know the principles, and they understand it quite well. But we want to give a better connection and link of the knowledge, and this could be through a learning tool that we want to develop. At the website of the University of Applied Science in Neubrandenburg, you have kind of information tool in this way. And this is a very, very good basement, because with this tool, you can get a lot of informations around your sector. And this is what we are planning to this tool we want to develop. We want to illustrate innovative concepts of circular bioeconomy in very, very simple ways. Yeah, I'm still drafting now pictograms and other material to illustrate this. And the target is that by clicking all these stations, that an action is happening. And with this action that is happening, you are understanding the process. Because when you are looking at one process, there is something before and something behind. And this is how it works in a circle. And the goal of this learning tool is that you are getting all this information by playing with this tool like a game. And the second part is we want to develop a teaching model and bring this into practice. In this topic, I'm in connection with Professor Gabe. My homework is now to develop a draft and that we can evaluate and think about how we implement this, because Professor Gabe would give us the chance to health, or how you say it in English, to teach this model in school when the draft is good. And so we are still working on it. And the plan is now that we are making a blog seminar that is multidisciplinary for all the different job profiles at the vocational school or at the university, when you are having your school, this seminar is a main seminar you have to learn about. And yes, this is what we are planning. And because when you look at the different learning plans, the lesson plans of the different schools and the different lectures, then you can see circular bioeconomy is not implemented quite well as a specific model. It's included and spread it in all these models you learn, and that makes it maybe harder to understand or harder to connect the knowledges. So we are planning to put it all together in one big model and give all the lectures the chance to visit it and learn about it. So today we want to take a closer look to concepts and technologies we want to bring into economy. And here is a list of different technologies and solutions. And relevant to this field trip today is nutrients recovery and pre-treatment of substrates, energy and gas production. And we are taking a closer look at it at the Domestorf GmbH. This is an agricultural organization, and they are producing plants and animals and food. And they share 1,000 hectares of agricultural land, and they have around 400 cows. And they use their residues in a biogas plant for energy production. And yes, so we want to take a look at 6 different stations. At first, we are looking at the feed store, then take a closer look at the animal and milk production, which kind of residues we have available, and other substrates, and how we pre-treat them for feeding the biogas plant with them. And yeah, then we speak about what kind of energy we are producing and what opportunities we have for development. Now we are taking a walk to the feed station, where all the feedstock for animals, but also for the biogas plant is taking place. And here we are passing digestate storage. Here, in the end, the fertilizer we can use to producing crops at the field. And with this fertilizer, we can fill the feedstock storage. We can see right there. Now a truck came and bring fresh corn silage into the storage, and here the substrates are laying for different purposes. And I will show you now the animal production. This is the second sector of this plant. Now we are going through the animals. They are growing here and producing milk.
for the regional market. They have fresh feed now. As you can see, the animals have a lot of space to move and have always access to fresh food and water. So this is very important for animal welfare. There's also a lot of fresh air here. And yes, the animals have a lot of items to deal with here, so a lot of interests for them, and they are very relaxed and healthy. And this substrate we will put into the biogas plant. And this is happening every day around 10 o'clock. Maybe we are a bit late for it today to see it, but this is also good because this would be very, very loud, so we couldn't hear quite well. Yeah, this is the material. It's mostly straw and manure. And yeah, now we take a look at other substrates we can use in the biogas plant with a material that is a bit different than the conventional substrate you use in biogas plants. It has much more fiber content. But interesting is the content of carbon. This is very, very high. So it is in biomass that is accessible for and suitable for biogas production. And the second reason why we are choosing just 10% of the amount is the amount of this material itself. Because to acquire this biomass, you need a lot of streams. And when these streams and water bodies are not near enough to your plant, then this is a very uneconomic approach. So to make this process efficiently, economically and ecologically, it is important that we acquire biomass from around 10 or 15 kilometers. And this is what we did on the water body 500 meters from here. We were collecting around 7 tons of biomass, and this you want to feed in the next 30 days to this plant.
Sebastian?
Yeah?
Yeah, I have a question. Do they have now a special pre-treatment device for it? A special pre-treatment system?
Could you repeat, because it was so loud here near the tractor?
My question was, do they have now a special pre-treatment system now for this type of material?
Yes, I want to show this to you. In the next station, we have at this plant now several opportunities for the pre-treatment of biomass. What you can see in front of us, this big machine, this is using the heat, the overheat from the CHP to dry substrate that is too wet for using it in the biogas plant. And in this machine, the biomass can dry for several days without any electricity or heat from external sources, because we just use the heat from the CHP. And this is a thermal treatment if you want. And the next treatment we can do in this plant is the mobile chopping. So that means we have a mechanical treatment of the biomass to bring it in a appropriate particle size for the biogas plant. So it's a kind of shredder, and this shredder is mobile. You can bring it directly to other biogas plants or directly in the field to work with the substrate. I just want to show you the technique. It's a very, very tiny truck, and in the inside, just a second, we'll open it. Yeah, this is a shredding machine, and we can bring the dried material into a particle size of 2 up to 4 centimeters. And this is good enough to bring it through the biogas feeding pumps. So now we had the point of the pre-treatment, so the mechanical pre-treatment for chopping and the thermal pre-treatment for drying. And also the storage itself can be a pre-treatment when you are doing it like silaging. So with respect to the substrate from water maintenance, this is a very important thing, because this to make silage from the material gives the opportunity that the fiber content will break a bit further, and this makes the treatment easier after it. So now we are here at the biogas plant. As you can see, we have 2 fermenters, and the big one is about 3,500 cubic meters, and the smaller one is about 2,500 cubic meters. And all the substrates we collect for feeding the biogas plants is collected here in the feeding pit. And in the feeding pit, there's a mechanical treatment of the substrate and to make it pumpable. So it's mixed with manure and corn silage and all the residues you saw earlier. It is mixed here in the feeding pit. Yeah, at the biogas plant, we are producing around 360 kilowatt hours electricity with our CHP, and this I will show you there. And in this CHP, you can see here, Gut Dummersdorf GmbH is producing electricity and heat for itself, but also for selling it on the market. So they have they're producing more than they need, not only because of the biogas plant and the CHP, but also from the photovoltaic plants on the roofs. So this company is doing a lot of small things to reach more and more efficiency and independency. And this is a very good thing for the future. What we also can bring in the future for especially this CHP is items in technologies in biogas upgrading or cleaning.
Then let's move on with the last part of this workshop. And in this part, I just want to continue with potentials and challenges in our region. And I just want to show you now some organizations and companies that are developing with us in the project, and also in the surrounding of this project, in the research field of bioeconomy itself, organizations that work with us together. We have a lot of innovative concepts to show. We take a closer look to substrate selection and pre-treatment and nutrient recovery. And I want to show you another interesting concept. It was planned that I also showed you an insect farm today in live, but this plan worked not so well as I expected. So unfortunately, the representatives of the insect farm I want to show you did not have the time today because of other dates and activities they have as a young startup. But nevertheless, I will show you how you can produce high quality fats and proteins from residual products and bee products. Yeah, the idea is that from harvests of cereals, using the residues for feeding insects, the production of insects is a very new and quite upcoming concept in agriculture. It's very interesting because of the growing rates and also of the high quality standards you can produce, for example, without antibiotica or others, but also having a good welfare. Of course, the insect producing is a very energy taking process, but for this young startup named Entava, creating different solutions. For example, they are producing 100% of their energy from photovoltaic, and they are using a very big heat pump to use the electricity and the heat for the insect production. And they put a lot of research into automation, energy independence, and innovative recycling procedures. And also they have a concept for outsourcing their production directly to the companies where the residues are coming from. For example, agricultural companies, they have a lot of space for taking the production of insects in their own locality. So with their concept, they take part into the development of running materials in cycle and producing or supply energy, food to their neighbors. And I was able to make a small image video of them that I just can show you and give you a small impression of this company. So I hope it will work now. I want to show you a small movie.
Yes, now we see the video. Thank you.
I'm sorry for this. Yeah, let's start again. This is Entara, a small startup in Rostock. They have a lot of products made from insects and mostly for the consumption of humans and for animals. And they are also producing byproducts like fertilizers. And it comes all from the residues from cereal harvesting. The bugs and larvae were feeding with it, reproducing, growing, and after the separation from residues, and then you have this very high quality material. And they were dried and pressed to oil and powder, and this you can use for several applications in food production or also technical applications. Another innovative concepts are, for example, in the land use. I will show you a small video if it's possible. And this is about using water buffaloes into landscape landscape care.
Dieser Heuballen soll zum Appetit.
Yeah, can you see the video?
Yes, we can see.
The background of this project is that for nature conservation, a lot of areas in our district are obtained to bring it into better conditions. So for this reason, often agriculture companies should give up these land and not producing crops anymore. The idea is that you can still have a production on these areas without destroy the natural functions of the system. So in this extensive cultivation of animals, we can achieve we can achieve that the area is developing natural, and this is here solved with water buffaloes. They are able to care about the landscape in a very natural way, and the farmers also have the opportunity to sell the meat and having profits from their land. The University of Rostock is investigating together with the University of Greifswald and some companies in the animal production how good it works, and we are investigating how the buffalo is interacting with the nature. What is he doing with the landscape, and what is the landscape doing with the water buffalo? So is he able to grow in a very extensive way here in this concept? And our experiences from the project so far are that the water buffalo have a very, very good impact in biodiversity of the landscape, and the meat is until now very exclusive, and so it's a high price product, and the farmers can earn good money with it. And yeah, the future will in the future we will see how we can bring this growing market, yeah, how we deal with this growing market, because it makes no sense to sell this this meat for the meat prices we have actual in our supermarket. That makes no sense, and this have nothing to do with the extensive concepts we want to achieve here. And move on with the trial we saw in part of the virtual field trip, the options for material and energy recovery of water care material. And this is the issue of my personal research, that to utilize this free available biomass resource in different ways. And one approach is to using it in the anaerobic digestion, to substitute corn silage, and to recover this material. Yeah, and with this innovative concepts, you are able to deal with biomass from your own land and also from streams surrounding. And yeah, you can use it, for example, for biogas production together with other residues of your company. Yeah, and these concepts we all want to illustrate in a way you saw right now. Another concept is Hofpostma. Hofpostma is a company that is working since more than 10 years with us together, with the Department of Waste and Resource Management. And we are doing a lot of trials with them together in a lab scale. Unfortunately, we are not able to work with them in an industrial scale, but for this purpose, we are here today at Domesdorf GmbH. They have more capacities for doing this. But Hofpostma is developing a lot in mobility, energy efficiency, water management, and resource and material efficiency. For example, they want to collect all the water that accumulate on their undrained areas into a basin, and there it should be purified by plants. And this purified water is reused again into the system, and plants they were growing in the purification are used in the biogas plant. So this is why they are interested also in testing water associated vegetation in their biogas plant. Another innovative concept is the production of packaging in the way that we are substituting plastic packaging. And this are we solving with a very, very interesting approach. Celto Green is producing substitutes for plastic packaging out of biomass by extracting the cellulose. And the cellulose is extracted in a new process they invested, and they invented, I'm sorry, and they are able to produce a very high quality and high resilient foil out of cellulose. And this is a very sustainable thing because it's also recyclable. Yeah. Another innovative concept area is the topic industrial symbiosis. In 2018 and 19, the University of Rostock was in cooperation with other partner countries in the South Baltic region for a project named Urban Baltic Industrial Symbiosis. And there we investigated the chances and opportunities in our region to reuse the end and byproducts from others as base products for your own. So it was in a way we find out how we exchange the residues between each other, and in this way we are using resources very efficiently. And in Germany, especially in the region of Rostock, we have two examples, good examples for this concept. The first is the Anklam sugar factory, a bit far away from Rostock, but they are using residues and byproducts in their sugar factory, and the residues they are producing energy with the biogas unit, and they produce a lot of heat and a lot of biomethane and electricity. Here you can see the concept in a bigger way, and what the inputs and the outputs of this symbiosis are. And another concept is the biological waste treatment plant in Rostock. And they are using the municipal solid waste and separate it into a solid and a liquid phase. And the liquid phase or mushy phase will go into the biogas fermenter and producing biogas, energy and heat. And the rest, the solid material, is going to a kind of thermal recovery where steam and electricity is produced, and the amount of residues out of it is very, very low. So yeah, this is a very big efficiency without a lot of residues in the end of the line. Yes, this were actually the part I want to present today. Now we are much earlier than I expected. So we have a lot of time to talk about the surveys or open questions and suggestions from your side.